So, the first proof. Here is an example of me writing on somebody's proof. Oh well, we'll just leave it like that. Here's the first proof. Cotangent plus tangent equals cosecant secant. In the first proof, if we go back to our examples, this first, or our strategy, sorry, this first proof really does the basic stuff. Change trig functions to sine and cosine and combine fractions to get a common denominator. Those two strategies are your like go-to strategies. If you can't see a shortcut or can't see a way to prove it any other way, that's what you should try first. And if you haven't tried those things and you come and ask me for help, that's the first thing I'm going to ask. Have you at least tried that? Now we're going to find out with some of these other proofs that these two strategies of changing functions to sine and cosine and combining fractions to get a common denominator, although it always works, it's not always the fastest strategy. But for this first one, it is the best strategy. Changing things to sine and cosine, that will get cotangent, cos over sine, tangent, sine over cos, cosecant, 1 over sine, secant, 1 over cos. Get things to a single fraction. The right-hand side gets to a single fraction right away, 1 over sine cos. The left-hand side, you have to get a common denominator. Okay, and then in this one, you get cos squared plus sine squared on top. And cos squared plus sine squared is 1, and you're done. This proof, if it was out of 3, would get 2.5 out of 3. What's wrong?
Yeah, equal sign. No, it doesn't.
No, equal sign is gone. A theta is missing here and here.
Bad.
Oh, so close. Proof number 2, and that is, I believe, for this proof, the nicest and easiest way to do this. Simple, no problem. Part B, cotangent cubed. Whoa. So first of all, you haven't seen, I don't know, maybe you got far enough to get to some with cubes, but probably haven't seen cubes before. Now these first two proofs that I'm going to show you are people choosing to change things to sine and cos. It works. It just is a little bit harder. So here, cotangent, cos over sine, cosecant, 1 over sine squared, cotangent, cos over sine. Get a common denominator. The common denominator will be sine cubed. And then at this point, you have a single fraction. Wow, that's a bad F, but we'll pretend it's an F. We have a single fraction, and it doesn't match the other side. Okay? So something that we're going to find out in our strategies, when you get things to a single fraction and things don't match. So maybe you could see if you change the other side to sine and cos, which is in the next proof, cotangent cubed would be cos cubed over sine cubed. And it doesn't match. So if we go back to our strategies, I am going to put a star, a big red star beside 2 of them. Build the other side and factor. Okay? These two strategies are strategies that you need to use when you get stuck. If you've changed things to sine and cos, and both sides are a single fraction, these are the two strategies that are going to help you. Either you have to factor something somehow, and that's what we're going to use in this one, or this strategy that I mentioned before, build the other side, see if you can make your denominators the same. And if you can make your denominators the same by building both sides up, by multiplying by 1, maybe that will help you prove it. So in this case, on the top, we might notice I have a cos in common. So in this step right here, the person factored out the cos. And once they factored out the cos, 1 minus sine squared appeared. And 1 minus sine squared should be something that triggers, just like sine squared plus cos squared equals 1. You should know that sine squared is 1 minus cos squared. Cos squared is 1 minus sine squared. So when you see that 1 minus sine squared, change it to cos squared. That gives you cos cubed over sine cubed. which this person changed to cotangent cubed. So changing things to sine and cos and getting a single fraction got you pretty far in this one, but it took that extra. When I get stuck after changing things to a single fraction, I have to think about factoring or build the other side. This one doesn't work to build the other side because, as we see in this example, which is done almost identical, except the person did change the left side to sine and cos as well. They factored as well. Once you get to this step, right, here is where you have your single fraction on both sides. You use the build the other side strategy when the denominators don't match, but these ones, you see the denominators do match. So we have to go to a factoring strategy. Okay. Now this is not the only way to do this proof. So changing to sine and cos, notice that this took this long. One thing I would say to this person, you do not need to rewrite the cos cubed over sine cubed over and over again. You can just leave it at the top and save yourself some time and just work on one side as you're going through it. So then someone else came up with this proof, which, as you can see, is quite a bit shorter. Okay? It's beautiful. It took them like 2 lines. What did they do? They changed the cosecant squared to 1 plus cotangent squared, because that's one of our new identities. Cotangent squared theta plus 1 equals cosecant squared theta. And at this time, one of the things that this proof here highlights from our strategies, this highlights 2 things. It highlights, I don't want to use black anymore, I used black already. Purple. It highlights using one of our Pythagorean identities. We have 3 of them. Sine squared plus cos squared equals 1, tan squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. They can often make your proof a lot quicker if you see them. It also highlights this strategy. Always be aware of your goal. Don't work on one side without being aware what's on the other side. And what I mean in this question is once this person saw the Pythagorean identity, once they did this right here, can you see that the left-hand side, the only trig function is cotangent, and the right-hand side, the only trig function is cotangent? And if you're only working with one trig function, usually you can get it to work out quite well, as is this case, because they distributed, and then cotangent plus cotangent cubed minus cotangent, those cotangents cancel out, and you just get cotangent cubed equals cotangent cubed, 2 lines, and this proof is done. And not too many people got to the last one. But in the last one, tan to the 4 theta minus secant to the 4 theta. First of all, those powers of 4 are going to cause some problems. And this one in particular is designed that if you tried to change things to sine and cos, it gets messy, just because of those powers of 4. So here's someone's proof. What they recognized is that tan to the 4 minus secant to the 4 is a difference of squares. It's tan squared minus secant squared and tan squared plus secant squared. If we see that, so as far as going to our strategies, this one, if I'm highlighting what we just noticed, right? That one's noticing that difference of squares. If you see that, then within here, we've got tan squared and secant squared together. So that also should trigger a Pythagorean identity. Because we have one with tan squared plus 1 equals secant squared. And what I would do with that identity, tan squared plus 1 equals secant squared, I would ask, can I rearrange this to get either tan squared minus secant squared? Or can I rearrange this to get tan squared plus secant squared? Which of those could I rearrange this to get? It would have to be the minus, right? There's no, if I move the secant squared over to this side, it would have to be minus. What would it equal to? I'd have to move the 1 over to the other side. It would equal to negative 1. So this person correctly worked with this one. What they did is they replaced the tan squared with secant squared minus 1, because that's what, if they got tan squared by itself, it would equal secant squared minus 1. The secant squared cancel out, and you're left with minus 1 times this, which if you distribute or if you factor out the minus, matches up perfectly. The other thing you could have done, any rearrangements of these, you're allowed to do one step. So you could have just changed this to minus 1 times tan squared plus secant squared right away. So if you can rearrange a trig identity, then you can do that in one step. So when you're doing your homework sheet with all those identities, some of them, let's see, does someone have their page here of all those identities with the smiley face on them? I would like to point out with, yes, thank you. With your Pythagorean identities, redo number 17 and do it in 2 steps. If you haven't done number 17 here, I'll put a picture up. Well, should we just do it together right now? That's probably better, because you're not going to remember. Okay, thank you so much. Here's number 17. What can I change 1 minus sine squared to? Cos squared. Oh, it's an x. What can I change 1 plus tan squared to? Secant squared. Cos squared times secant squared? Because this will be 1 over cos squared. I mean, if you want to take an extra step, you could. Choo, choo. Make them go away, and then you get 1. Sound effects are good while doing identities. They make them that much more enjoyable. Okay, and you're done. Left side equals right side. So much quicker. All right, the ones for practice are 3, 5, 6, 8, and 9, Oh, not 8. 7, 7, not 8,